All right, welcome back. We're making a game, side-scroller RPG game. Last time we implemented some animations, and well, one animation, but the animation system, some sort of. I'm thinking I'm just gonna put this in a separate function so that's easier to read here. So I'll just say update animations, and I guess we can add animation system in there as well, like this. And we will also have the scene here, and also we need the time. Okay, so we just put that back there, and we can just say update animations here. See, okay. All right. And let's also say update player animation. So we get all of this in there. All right, and then we need the key as well. So see update player animation. There. Okay. Let's just see if this still works. There we go. Oops. Let's see. There we go. Okay, yeah. So this still works. And is animated. Okay, cool. So what I want to do is actually, as you can see here, yeah, both I want to fiddle with the physics a little bit. As you can see, there's no friction. So the dude is basically just gliding around here. And also the gravity is really, really slow. So I'm thinking the gravity is actually based on like Earth gravity right now, but it's like meters. It's like the unit is in meters per second squared, I think. And the issue is that the unit that we're actually having in the game is not meters per second squared, it's pixels per second squared. So what we want to do is we want to translate from pixels to, or from meters to pixels, or yeah. So either we just keep everything as meters, and then when we actually draw stuff, we draw them, we have to translate when drawing, or we translate when dealing with physics. I think the easiest is just to deal with it with physics. So for instance here, like all the velocity, all the acceleration will actually be in pixel units. So what we could do is we could do this and then do pixels or meters to pixels, and we will have that as a constant, meters to pixels, and that would just be a factor that you will have. So this would be like how many pixels are in 1 meter. So I guess pixels per, like if we say 1 here and we say this is actually pixels per meter. Okay, so how many pixels per meter? I guess if the character is how many pixels the character is 32 pixels tall, and let's say the character is like, I don't know, almost 2 meters maybe, then the pixels, then you have 32 is almost 2 meters, so you would have 32 pixels equals, let's say 1.8. So you would do 32 divided by 1.8 to get that. Oh, and let's do that. Okay. And let's see. Yeah, we get a much more. It feels a little bit slow, to be honest. Oh, wait, I know what the issue is. So we are actually scaling the player as well. So let's also have the scale. I think it's 3. Yeah. So let's actually put that in. What's this? Oh, this is something else. Okay. So let's put that in a variable or a constant. So we have scale 3. And then what we could do is pixels per meter, and then we also have to scale this. So we have to say this times the scale, because that's the actual height then. And there we go. Now it feels a lot more like Earth gravity. Okay. Yeah. And okay, so that's gravity. And now we also want friction. So that's going to be a bit more complicated. Well, depending on how you want to actually implement this. One way to implement it is like you figure out if the player is on the ground. Like when the player is on the ground, you apply some sort of friction, which goes against the velocity. Some sort of like friction force that goes against the velocity until the player basically stops. And if the player is in, or if the thing is in the air, then there's no friction. Or you could have like air drag, but it depends on what kind of physics you want to have. I'm not sure if I want to have air drag in this game, but I definitely want some sort of friction when you are on the ground. So what I'm gonna do is basically so there is not really any way right now to know if you're on the ground or not with the physics system. So I would have to implement either like a real friction system or just it. My physics is not more gonna be more like arcadey style physics. It's not gonna be like super realistic. As it is right now, it's got some good collision detection going on, but I would want some sort of ground friction. So I think what I'm gonna do is I'm just gonna go to my physics system and I wanna just have some sort of ground physics or ground friction physics. So as we have gravity over here, which is a special kind of parameter, I want some for ground friction as well. And this would just basically just be a scalar that determines the strength of the friction, I guess. Maybe it can go from 0 to 1, something like that. Like from 0 you have like no friction, and 1 you have like a lot of friction. Maybe even, let's see, maybe we can even have that on the rigid body itself. But then the issue becomes that you don't want the friction to be, because I only want the friction to apply when you're like colliding with the ground, and the ground like a level kind of ground type thing. Well, let's just start here and we'll see how we go, because the way the ground is implemented is just another entity that's going to collide with other entities. And maybe we can even do, let's see how you would do this. So maybe we can say every time we collide, we apply the ground friction if the collision is in such a way that it's probably need to be applied. So don't want to apply it when the player touches a wall, for example. It's only going to get applied when you're touching the ground. And we could, I believe, actually know that because all collisions have like an axis and a depth. Well, I guess you would only need the axis, really. And I guess you would just check. So let's see. So what we have is, yeah, let's just set the ground friction to, I don't know, 0.5 or something, or 0, yeah, I don't know, 0.9, something like this. And then we check here. So we have collisions, and we are resolving the collisions. And we should also have, okay, yeah, this is the collision system. Yeah, we have this event. So we are emitting, we're not emitting the events, that's right. So we would like to emit the events because that's how you would get the events from outside of this, I believe. So you would pull the collisions and you would get the event from that with a callback. But this event, I believe, is a bit different because no, it's the same. Okay. So let's just do that. And let's go. We are using the quad tree. So we want to emit that and we want to emit the event as well. All right. And then this would be, well, actually, the collision actually has the, I don't think we actually need the event per se, because the collision itself has the rigid bodies here. So we don't even need this structure anymore. So let's just delete that. And let's delete these things. It's using for debugging purposes. So we are in the quad tree. We don't need to create the event. We can just pass in the collision right here. Let's also do it there so we don't get some weird issues here. Actually, let's just put this back. This, okay. And collision events. So this would be just collision. All right. So we basically store them because the pending collisions, like I'm not going to explain the whole thing, but the reason why we have two things here, it looks a bit weird, is because the pending collisions is used internally in the PhysicsSystem to resolve the collisions. And these ones are exposed to the outside, so you can poll the collision events and see what's happening. So emit the event, you would need this. And then poll collisions, you would need this. Okay. And that's it here. And now we can go to our initial scene. And after the PhysicsSystem has updated, we can poll the events. or the collisions. And this would be initial scene, I guess the pointer. So that's the context. Scene. And then you need an onEvent function. So this would be onCollision. Oops, and let's just put that there, and we have the scene and the event. And just call it collision. Okay, so that's that, and we need to pass that in here as well. So onCollision. All right. And we also need to import the collision. Physics. So we'll just put that here. Collision. Make a physics section here, not shape. Physics. I guess we could have this, and then translate that. All right. Now these aren't used, so okay. So here, so I guess this isn't happening in the actual physics system. I guess. Well, whatever. Let's just implement it here, and then we can move it later. So when we have a collision, we want to check. So what we get here is that we get a, well, these don't exist yet. I haven't done anything with the contact points. However, the normal actually exists, and the normal is going to be something. So I might want to draw this normal or just log it to see what it is. So let's log that. So collision normal. So that's the normal. I think that's it. I think that's the only thing that I really want to use, actually. And it's not marked as public. Okay. Oh. So, right. Let's just pop that. Okay. All right. So let's run this and see what we get. Okay, we should have gotten some. Yeah, we got. Okay, interesting. It's like pending between 0 and -1. So I guess it's 0 and it's when the velocity is like 0, and then it gets -1 when you reach the ground. So I think what we want to do is okay, so that's one thing. I want to also test if I move a bit and see. So it's still like -1. So what I want to do is I want to say whenever we get -1 on there, on the Y, so yeah, that means that you're like exactly hitting a flat ground with a flat surface. So I guess we could just say if collision.normal.y is equal to -1, that means that x is 0 because it can have a maximum length of 1. So if y is 1, then x can't be anything else than 0. So if y is -1, then what we want to do is we want to apply some friction force to the player or to the entity, which is not static. So I guess I also want to check if we are static as well. So we want to get the if one is static and the other is not static. So non-static, I'm gonna say this is collision if body A is static, because we're not gonna get a collision between two static bodies because that's not happening. So if this is the static one, then it means that the body B is the body that is not static. Otherwise, body A is the one that's not static. So now we have the non-static body, and we want to apply the friction. So what we could do is apply a force, and the force would be something. So for friction, there's basically two different types of force: the static force and kinetic force. And static force is a force where if you have an object that is at rest touching the ground, to make just imagine that you have a box on the floor and you want to push the box. Imagine that it's quite heavy box, and so it requires a bit of force to actually get the box moving at all. But and that's the static friction in place. But once the static friction is overcome, it's it has a limit to it. So you push harder and harder, and eventually the box will start to move. Then the friction is actually less now, or it could be less. Technically, it could be more for kinetic, but as I've read, I'm not an expert on this, but from what I've read, like you have a kinetic force that comes into play when the static force is overcome. And the kinetic force, I believe, is usually less than the static force then. So you would push the box, and then you don't have to apply as much force to keep the box moving, is the point. I'm not sure if I'm gonna implement that here. I'm just gonna implement some force that basically I want to have like a static force. I guess it should match the velocity up until a certain point, or the force, I guess, the force that we have along the floor. So to get the force, you take the velocity times the mass to get the force that we have already, or the momentum, I guess, because the force is going to get divided by the mass to apply to the velocity or acceleration. So we can take the non-static velocity, and we take the negative, and we also scale it. So I guess the momentum, which we don't really have I guess we could add that as a could add momentum as a helper here. Do we have any physics related helpers? I don't think so. Well, let's just start. So let's have a momentum. And this is going to be a scalar. Wait, no, it's not. It's going to be a vector. And this is going to be, so it's going to be the velocity scaled by the mass, which is also like calculated. Yeah. Okay. Okay. So in here, we can take the momentum. So now we got the momentum. We take the negative of the momentum. So now we basically pointing in the opposite direction that we're moving. And we are applying this force. Now if we actually just leave it like this, we won't really get anywhere. Let's just try this out and see how that works. So what we also want to do is we want to check. So we want to check that both of these, well, actually, I don't know. No, I was going to check if both of them was solid. But never mind. Let's just try this for now. And this should result in the dude not able to move at all. Or not. I guess he can move. Okay. Well, I guess it was only happening like every third frame or something like that. Is he even slowing down? Yes, maybe. Let's actually log the velocity. All right. So the velocity is slowly going down. I'm thinking actually what I'm also remembered is that we talked about a little bit about meters, the unit, and I think I know why it's slowing down, not really by much, is because, well, I guess the mass doesn't really matter since it's gonna be always the same because we're dividing and multiplying. But what I was thinking is that the mass is not accurate because it's also in meters, or it's grams per square or cube meter. Grams per meter cubed is what the thing is, and the unit. So, but the actual unit is pixels per thing. So the density that we set the player to be should actually be actually multiplied by pixels per meter. I think that might be. Yeah, it's I mean, it's still the same result, so it doesn't really matter. But it makes the human actually way more difficult to move. Let's just not deal with that. I'm not sure if that's the correct thing to do here, since the unit is grams per meters cubed. If you just scale it up by pixels per meter, what you actually want is, yeah, I'm not sure how to convert that. I'm not going to think about that right now. It's not really that important because it doesn't really solve the issue here. So where were we here? So I wonder if we should include the ones where the length is 0. Let's have squared. If it's 0, let's also apply the friction. Okay, so there it happens a lot faster. But I thought it was gonna make him not be able to move. so that's the velocity. So let's check momentum. So it's really low. Let's see. So what? Because it should be it's scaled by the mass. So what's the mass? Even if it doesn't really matter, I'm curious. Also, I wonder why it shows. So the mass is like really tiny. Okay. I guess I'm not sure why, because according to the mass, it should be like the mass. I think it's in kilograms, so it should be like and the density is human, so it should be a lot, since each pixel should be like 1 meter. Or the volume. Well, I guess it's a flat human, but it should still be a lot. It's like, okay, so it's like 16 times 32. So what's the volume? Let's say a human is a cylinder of, I guess, a third of a meter times a third of a meter times, I guess, 2 meters. So 0.18. Or let's say half meter times 2. So 0.5. So that's, wait. Yeah, that's the volume. Wait, that's meters cubed? So grams, and let's say you weigh, as normal thing, 100, and the volume is 0.5. So would it be 50? And then since it's grams, you add 1,000. So it's 50,000 grams. And then because the density, wait, so this should be like insane amount of mass. But it's like -3. Like to the 10 to the -3 of mass. I don't understand how, because the volume, oh wait, density over the volume. Wait, what? The mass is it, wait, shouldn't it be times? Wait, what's this? The mass equation. Density times the volume. What? Why am I dividing here? Okay. So so let's just do this. And let's just return this. So whoops. Volume times the density. There we go. Okay. It shouldn't actually matter. However, yeah, the mass is, now it's correct. Okay. The mass is insane now. So I think what we need to do is actually divide the density. I think we actually need to divide by pixels per meter to get a sane density. And the volume is not, I guess the volume is also wrong because it's in a, okay, let's just do this. And I guess when we apply the force, maybe we will, it's just a mess to try and calculate this or have it be everywhere. And this, we're scaling it by 3. Let's just scale it by this, maybe. Okay. So now the force is stopping us. And let's get rid of this. Okay, so we're still standing still, basically. And so we want to scale this by this, and then we also want to scale like the speed of the player. So let's just have 10. Okay, so maybe, so this would be like, in theory, meters per. Okay, I'm not even gonna try and I'm just gonna add so that we get something here. Because if you look at the mass is like 500 kilos, which makes sense since the volume is supposed to be like 500. If the volume was less, then okay, so that looks more like it. Let's increase this a bit more. Let's see. Okay. But now the velocity, okay, the velocity really, it does change. It doesn't actually change. Oh yeah, because I removed the thing. Let's do this again. Okay. Okay, so now you can see that we're basically moving a lot slower. We're basically coming up to a maximum speed now. I mean, I guess that's kind of the effect that I want, actually. However, I don't know why it doesn't. I guess because when you're accelerating, we're applying a force and then plus the actual velocity that you have. So we're actually not negating the acceleration that you get by walking as well. So we're getting friction, but and then okay. So I want to do a couple of things. So one is just adjust this so I mean, we can keep this kind of algorithm. But one thing that I want to do is when the player is moving slow enough, I want the. So how slow are we moving here? We're moving like. Yeah, we would look at the velocity. If the velocity is less than. So let's do if the velocity. And let's do like it's less than some sort of slow threshold, like body friction stop threshold. Then we want to set velocity to 0, 0. Or I guess 0 and then no, 0, 0, because we are on the ground, so we should be not move. Okay. Else we want to do this. Okay. And we don't have this constant, so let's define that. Now this is so about, I don't know, 20, like 10 plus 10, 10 squared plus 10 squared, 10 squared. So this would be about 200. Let's try that. So if we're below 200 in velocity length squared, then we want to stop. There you go. Oh, and now we can't move at all. Oh, because we're not accelerating enough. So I guess if we are accelerating, we don't want to apply this stop here. So let's get this acceleration length squared. If accel length is more than 0 and, or if it is 0 and we are moving slow, so let's do is accelerating is equal to 0 or is more than 0 and it's moving really slow. I guess we'll do this. So if we are not accelerating and we are moving really slow, then we want to stop. Otherwise we just apply the friction. Okay. All right. Oh, we still can't get this guy moving. I wonder if this is because we are doing this. So we're doing this after the physics update. Oh, right. And after the physics update, the acceleration is actually always going to be 0 because it does updates and then it sets acceleration to 0 so that you can next time call apply force, which gets added to the acceleration, and then it resets the acceleration. So we can't actually use that here unless we save the old acceleration in the body. Yeah. So maybe we should check. I mean, this should be. Maybe we should check velocity instead. No, it's acceleration really that we're interested in. So, I mean, it would be nice to be able to look at the acceleration that we actually had also. So maybe we should actually just implement the acceleration, like previous acceleration, in here. So let's do that. And let's set this to 0, 0. All right. And let's go to the physics system. And update positions. So after we've updated positions, we also want, I guess what we could do is go in here and say, well, we don't really have, I think we should just say update previous accelerations. What's this? Oh, this is the old one. Let's remove this. Yeah. That's the really old system that or update position that I had. So this would have a self and yeah, I would just go through. So we would need a view or yeah. Let's do, or maybe we have it here, like a body. Which view? Do we have a view? Which view is this? Yeah, so we have that. So we just need to loop through. So this is a view of rigid bodies, a basic view. And when you have a basic view, you only have one component. And since ECS stores the components in like packed lists, basically, or not packed, but yeah, these slices you can get at these slices directly. So you can just say this raw, and you would get the body directly here. So this body is a rigid body. So also I want this. Okay. Now this. So what I want to do is set the previous acceleration to be this. Actually, we want to do this before we update the positions. Yeah. So we save the accelerations here, and then we have the positions and reset the accelerations, and then we have access to that. Okay, and then what I want to do is I want to go into here, and I want to make a. So maybe what we should do in this case is actually change this implementation to get the previous acceleration actually. Or we could just make a new function which says previous acceleration, and we get. Well, actually, we can just access it directly instead. So this would be previous acceleration like this instead. Okay, so now we are saving the acceleration. Come to a stop. No, still doesn't work. Okay. Let's bring the. Oops. The log back. So it's accelerating. Oops. Accel length is moving really slow. Okay, let's try this. So I'm guessing that So it says it's false. Okay, interesting. So does it not get updated? What? I'm pretty sure this is called, yeah. Oh, it's called several times because we have physics substeps. So we actually need to call it here. Because we have like each physics step, each frame, the physics system has to be called several times because of the simulation gets wacky otherwise or less accurate. So we have these physics steps that we calculate how many we need, and we do the physics update a whole bunch of times, and then so that's gonna cause the acceleration to only be applied once, I guess, and subsequent will only deal with the velocity. Maybe that's why the collision only had collisions like. Maybe that's an issue, actually. I've never thought of that. Maybe the acceleration is not quite right in that case. I'm not yeah, I mean, what it should be the same, right? Yeah, I think so. Yeah, I think this is actually a bug in the physics system in that case. I mean, I guess it doesn't really make that much of a difference since it already works. But I think when we call this, yeah, no, this just updates. Wait, no, it's here. Update positions. Yeah, in here. So yeah, here we actually reset the acceleration here. But we don't actually want to do that. So we want to do this after. So we want to have an if function, which I guess would be called, well, we want to run this after all the physics step is completed. So end physics step, maybe. All right, had a little break there. Now we're back. So, okay, yes, we were adding a physics step that's supposed to be run at the end of every physics step, I guess. End physics not step, but I guess update or frame, or yeah, let's just call it frame because it's supposed to be run at every frame at the end of each physics thing. And we need this. All right, and now we set this. Okay. So I'm not really sure how much this would affect things, but I think since the dt gets divided by the number of physics steps as well, I think. The substeps, I guess you could call it a step. Yeah, whatever. Yeah, so the dt gets divided by the substeps, and then you get another dt which is smaller, which is passed into update positions. And then when we're all done, we need to say container and physics frame. All right. So let's see if we can run this. All right, there we go. And yeah, I mean, looks a bit like before. Why is the animation still going? Okay. So let's just assume that this works. And let's go on. Oh yeah, so we have these. So let's select like this. And we can see that okay, we can see here. So we do have acceleration. Oh, because the acceleration goes down. I see. So now we always accelerate because of gravity. Okay. Oh, I'm not sure what happened there. If something happened that's not supposed to happen. Okay. Okay, so it didn't really solve the issue. because because we always get gravity. Let's see. Well, I'm curious because the physics, if we look at here, where's the gravity actually? Oh, we're passing gravity here. And then we actually, but then we apply it here. Oh, wait. Yeah. So we set x and y to 0. That just means we set it. Yeah, we set the vectors, everything to 0. And we're applying gravity. So we actually this one. Yeah, the acceleration is modified, but then it's reset. And we apply the gravity before we actually go into update positions here. So I'm not sure why the gravity is pulled in, is added here, actually. Because we're applying the gravity here. We're actually applying the gravity, right, we're applying the gravity several times now, actually. So that's not great. And we're not taking dt into account, I guess. Maybe that's an issue. Should be affected by time, of course. I mean, it's just like applying a force, except it's not a force. It doesn't take mass into account. But right, we are taking acceleration by time here into account when we calculate the velocity. However, since we're not resetting the acceleration now, this will actually set the gravity. So what we would need is start physics range as well. And then we need the gravity. And then we don't do this here. We actually do it here. And we can also do this. And we do not need gravity in here. Okay, so we do gravity one time, and then these steps will resolve with dt in mind. But yeah, we also do this. So yeah, I haven't explained this thing here, but yeah, I'm not gonna go through this now. But it basically uses vectors, like zig vectors, which uses vectorization, like SIMD operations to do all these physics calculations, like calculating the velocity from acceleration, position from velocity, and yeah, the rotation. But the rotation is actually not implemented fully yet, but let's see. So, well, you can rotate things, but it's not implemented fully everywhere. So it would be a bit weird. Yeah, so now we actually we apply the gravity one time, we do the update positions a bunch of times, and then we reset the acceleration one time in the end. Okay, so we don't send in the gravity here, but we do need to call the start physics frame, and we do it like after we do it after the update previous accelerations. So now we should not get the gravity. I'm not sure even if it was the gravity that we actually got there. But let's see. Okay, so wait, what happened? What is happening? It lagged a little bit. Not sure why. Okay, we still get some sort of acceleration, which is really weird. Why are we getting that? I'm not sure where that comes from. So this means at this point we have acceleration, even though we're not actually accelerating through, because I'm not touching, I'm not moving the player, and it still has acceleration. So that's the issue. We are applying some sort of force here, but it should be 0 when we're not touching anything. We're not applying. I mean, we are applying this force, I guess. But it should be 0 because the velocity is 0 as well. Let's see, what is the momentum here? Momentum, okay. Let's see what that was. Yeah, it's looks like it still has momentum. That's weird. Is it because of the gravity? And the momentum doesn't, like the velocity doesn't reset? What was it? So it's like 30, it like, also it maxes out. I'm not sure why it maxes out here. Is it because I'm applying? Yeah, because it shouldn't actually go in here. Wait. Maybe this is the issue. Let's remove this or here. There we go. Okay, but we still get momentum. Is it just because we are applying this force? Because we're moving really slow. We set it to 0, so we shouldn't actually have a force. Let's only say here. Yeah. So we still like, right, so because the magnitude of the velocity is so high, probably because of gravity, but the actual velocity is not that, because we're standing still. So is this an issue with the collision resolve step? Right? I mean, it stops it changes the position. Now we're in the physical collision resolve function, and this, I guess, is, yeah. See if I can remember what's happening in here. So wait, if this is not static, we set velocity. Right, so this is velocity being set here, and this is position. So the velocity is being, I mean, I guess if the other one is 0, then we should set the velocity, then we should it should be set to 0, right? So here we're taking the velocity of A. So let's say that's the player and B is static. And we should actually, this should be infinite. So we divide by infinite. No, not mass A. Mass A is not infinite. Wait, shouldn't this be mass B? Or should this be mass B? Something is wrong here. So J is some weird calculation here. We got the relative velocity, so that's how fast they are moving towards each other. Then we scale it by, okay, this is restitution, the minimum restitution, and then fiddled around with. Okay. And then we do a dot product against the normal, so that's against the axis of collision. So that will yield some sort of magnitude, which is either positive or negative. And then we divide that by some sort of mass calculation. So it's like the speed of collision divided by, or actually this looks like it's actually, I mean, it's more like it's scaled by the mass rather than divided by, because if you have A divided by 1 minus B, wait, no, 1 over b plus 1 over c. Shouldn't that be equal? I may just put this into Wolfram Alpha because my algebra is lacking right now. Okay, let me just put this in Wolfram Alpha and see what it says. A over 1 over b plus 1 over c. Alternate form is a times b times c over b plus c. Okay, but that gets rid of like 2 divisions, which has variable, like unknown, like runtime values. And those are very expensive, by the way. So instead of, so what we could do is we could take this part. So let's say that this is A. Let's say JA. And JB is actually, so this would be JA times mass A times mass B. And then over mass A plus mass B. Yeah, so that's the same thing according to Wolfram Alpha. That's an alternate form, which is way easier to calculate, or easier for a computer to calculate anyway. Okay. All right, so yeah, also as B, if mass, if so, also here, if A or B is infinite, so if B is infinite, then we just take B out of the equation, or we just say, that the answer is A times C. So we basically remove this entire thing. If B is infinite, we remove this entire thing. And if A is infinite, yeah, we do the other way around. So, but yeah, that should work. What happens here? Wait, what happened here? Oh, I did something very weird. Okay. Okay, now. Yeah. So, yeah, the velocity is not really set. I mean, maybe we should actually set the ground to have like infinite mass or something like that. So I'm not sure, like what happens in SIG if you divide by infinite? Shouldn't it be like 0? But it's not, it shouldn't be 0 because it should be what it said in the limit. So let's actually do this. So let's say that if mass A, so I think is infinite. So if mass A is infinite, let's do that. Then it's going to be JA times mass B. Else if mass B is infinite, then it's going to be a JA times mass A. Otherwise, it's going to be this. All right. Okay. Now let's go over to, I mean, I guess we could say that all static things has infinite mass. I guess we could change that in the physics system here. So let's go to where we add the body. Oops. Here. And let's remove this log here. Okay. So if we are static, we don't set mass here, I don't believe. No. Where do we do that? I think we just take we have the static params here, yes. And we just do this. Okay, so we can just say here that if static is static, then we set the density to be infinite. Okay. Oh. You can't modify the parameters, so I don't want this to be a pointer. So what you would have to do is like use a var here. I'm sending in this here. And so what I need to do is actually need to set this over here instead. And this should be body. So if the body is static, we will set the density here. So this body is actually, because we add it into the registry, so that's where the actual data lives. And to be able to modify it is, I mean, we're sending in static here, but that's just a bunch of values stuck in a struct. But the actual place where the body is living is in this registry here. And then to modify it, we need to get it back from the registry once it's been added. And then we can modify it. So here we check is static, and here we set the density. Okay, so let's see if that breaks anything. Okay. Well, it didn't actually work. But let's see what it says. So, okay, so it's like even worse. Great. Did I do the wrong thing here? Let's check the math. So in the limit, if b is infinite, then it's ac, ab. Okay. So I mean, well, I deleted the old version, so I don't really see how it worked before. But I believe it was something like this, like let j is equal to this over 1. So 1 over mass A plus 1 over mass B. Like this was the original thing. And so we just took this as A, and this is B. Oh, yeah. And this is C, yeah. So, I mean, this seems to work, like the last thing here. This seems to be the same thing. However, this part might be, I mean, it should work. It should be. I'm not sure if the mass is actually infinite though. Let's add math to the log. Let's add mass here. And let's also get the static body. Okay. We want to get the mass of the static body. Mass static. There. Let's also format it here. I think it's D colon. There. All right, let's see. Yeah, it's infinite. So why? So yeah, okay. So I guess the logic behind this is, or the insight that I just realized, is that if you're trying to push something that has infinite mass, of course it's not gonna move. Because no matter how much force you apply, it's never gonna move because it has infinite mass. So maybe it should have like 0 mass instead. So if it has 0 mass, then this equation becomes 0 and the whole thing becomes 0. Which means that this becomes 0. Also, one of these should be, I'm not sure what it would be. Would this be mass B? If this mass B, this should become 0. Yeah, the velocity should still like be set to 0. I think this is the issue here. This should be 0, I think. Let's try that. Alright, had a little break there. Now we're back. So, okay, so I'm not sure if we actually tested this out. Let's see. Yes, maybe. Maybe it's gonna be the other way around, I'm not sure. But anyway, it seems to not work as I intended it to be. I mean, shouldn't this be 0? And then this should be 0, and then this. So basically nothing happens, is what it's telling me. Because the thing is that we want to reduce the velocity by the same amount along the normal. I guess that this would be, maybe it should be like this. Because now J should be, it should actually be just this times the mass. Okay. Okay, that looks way better. And I guess the friction works a little better as well. Oh, but we got a problem. When we stand still, we don't actually have direction. So we actually need to store the direction in a separate variable. We can't rely on the velocity since we don't know the direction when it's 0. Okay, but that actually solves the issue here. So that's nice. All right, so we solved a bunch of problems, and now the character can walk, it can stop, even though the friction might be a little bit too low. So let's try and find a good... I'm gonna keep this around, but now this looks nice. And having a static body actually makes the mass infinite, and it actually works really well. Okay, so let's remove this, and we don't need this. All right, cool. So we could raise this threshold a little bit. I think we want to raise it a little bit. And we definitely want... We might even raise it more, but we definitely want to scale this vector here. Like, it's also kind of weird because I feel like this should actually... The momentum should counter the velocity vector like perfectly. So why is it not really doing that? Is a question you can have. So handle input is done first, yes. And then we do an update, and then we pull the collision. So this is after all the updates. So the acceleration should be the acceleration that was just applied. And then we take that velocity that we have, and we apply the negative. I mean, there might be something wrong with the physics simulation, but I'm pretty sure... Actually, I'm not pretty sure, but it feels like this should negate the entire thing. I mean, I guess it also takes time into account. But this is like one time step, like one frame. And this is also, it's like we're adding acceleration to velocity, or velocity to the acceleration. So maybe we should actually maybe we should do this... No, we can't do this before the physics simulation. I mean, it should really be done in the physics step, or the collision resolve step. But let's just scale this by 2, see how that works. Okay, let's scale it by 10. All right. Yeah, that feels a lot better. We're stopping almost immediately. There's a little bit of sliding, but it's probably good. I mean, in the end, we might even not have the apply force method at all, and instead just use. So when you stop, you actually stop immediately, because that's how many of these games with sort of arcadey physics have the feel. So it would be something like, I don't know, Symphony of the Night, Castlevania, like any Metroidvania, basically, like Metroid, with these fluent controls where you actually stop, the character actually immediately stops. And you don't even have friction. You basically just have a little bit of acceleration. But, well, for Metroid, I guess I'm thinking about Super Metroid, you have a little bit of acceleration. But when you stop, you actually stop instantly. And then, yeah, you have a little bit of air control as well. But I'm not sure exactly how I want the physics to be. But I guess I can start here, and we'll go with this for now. Also, I realized that the speed that we're going in here, yeah, you can see it already. Like, let's say that you actually can. You can see here the air control is way more than, because on the ground we actually apply friction, but when you're in the air you can move freely. So I think what I'm gonna do is, well, I don't want to have. Maybe we should always apply this, even if you're in the air, but then only in the horizontal. Yeah. So I think what we'll do is not even on collision. This is just going to be a friction step, like update friction. And we are going to get a view of the body. So this would be a basic view of rigid body. And then we have raw, which is the body. And we also want it to be a modified pointer. Okay. I don't know why it doesn't seem to work here. But it shouldn't be momentum. It's gonna be, well, it's gonna be momentum, but only the X. So let's scale it by the unit X. I mean, I realize that that's not really an efficient way of doing it, but it was easy to think about doing it like that for now. And yeah, we want all these things. So we'll comment this out for now, because Yeah, I don't even think we're gonna do this anymore. So that whole thing was unnecessary, well, for now at least. So let's change non-static the body. All right. Okay. So now the friction should apply. Okay, so what happened there? Right, so we're not calling the events anymore, and that means that the events will basically stack up and eventually overflow. So we need to disable emitting the event that is here. So we're just gonna not call this. Okay. Whoa. Okay, seems like, oh yeah, we're not calling this function. So we should call this function maybe even before physics update. Oh, yeah, this needs to be multiplied. I'm not sure why I'm not getting the LSP for this. I believe this has worked before. But maybe, yeah, I don't know. Okay. Whoa, what happened? Oh, I also need to check if the body is static. Then we continue. Okay. Oh, we're falling really slow now. Wait, why? Oh, this should be in here. There we go. Okay. Yeah. So we're only applying this on the horizontal now. Okay, cool. Might either change this scale or change the speed. So let's try change, because I want the character to move a little bit faster. So let's go to handleInput. We're scaling by 5,000. Let's try 10,000. Yeah, okay. That feels a little bit better. But the stopping doesn't work now. Okay. Okay, so let's see. Right, because we're always, no, we're not always accelerating. But now we actually update this before the physics, so we can actually look at the acceleration directly. Yeah. Okay. Cool. And we're stopping relatively fast. Awesome. Okay. Now I may want to increase the speed actually a little bit more. Let's try 15,000. All right. Yeah, I kind of like this having like a more slow paced walking as well. I mean, for the combats, becomes a little bit more tactical than more than Twitch based. I mean, I like Twitch based also, but I like tactical as well. I don't know. I'm really torn between how I want this to be. But let's just get a foundation going. So yeah, so okay. So now we got gravity working as it should. We got the character moving around. The friction works really nice. The character stops uh, almost instantly when you let go of the button. And there's a little bit of slide, but I'll let that slide, but don't dish. And yeah, the animation works good. And yeah, I mean, well, I just realized one thing that I might want to do is whenever you can see here is like if I stop and then turn on the animation again, the animation is still like it looks like it's almost going. So what I want is the animation to reset to the first frame after you've actually stopped. So let's actually do that. So um, I could go to update animations, update player animation. And if we are going into idle, then we actually want to set the frame to be 0. So that way we always go back to the first frame. Yeah, that feels better. Okay, cool. Okay, so yeah, next up I want to do the direction thing I was talking about. So we need to have some sort of direction. I feel like either we can just add a component, but I'm just gonna add like a player component. So player component, and this is a struct, and I'm just gonna have a direction here, and this is gonna be like either left or right, but I will say, yeah, so this would just be like, I mean, it really depends on, it's like the intent, the direction intent that you're doing. So it's going to be either left or right. So I'm going to say it's a player direction, and a player direction is a enum where you can go either left or you can go right. Okay. And we are going to import this player direction. Or player component, sorry. And in our load function, where we add the player here, we add a bunch of stuff, so we should also add the player component, and direction is, we can start at left. Okay, so now we actually have a direction, and we want to set this direction based on which way you're intending to go. So we're gonna look at this one, and if we are intending to go to the left or right, we want to change that direction. So here we actually want the player component, and we get it by saying get player component from the player. And if we're going, A is to the left, so player component dot direction is equal to left, and here is equal to right. Okay, and then we need to change the animation here. So we're not looking at the player x dot, we are actually looking at the player direction. So let's get the player component as well. And this would be direction. So if the direction is left, then, or right, actually, yeah. If it's right, then we want to flip. If it's not, then we don't want to flip. So let's also have that as a thing here, because it will always happen. Okay, now we should actually see the player, hopefully. So it should start out left, and we change, well, it resets. Why? Oh, wait, no? Why did it? Did I forget to save or something? No. Uh, wait. No, wait. No, but the. Oh, the texture is set here to Pistling Idle. Okay, so we need to do this after here. Yeah. We need to do it down here because over here we're overriding the values, and Pistling Idle actually has left as, or horizontal flip false. So we need to update it after the thing is updated. Okay. Yeah, now it works. Okay. So now we actually have our character animation working, and we can flip, move the other way. And it all works pretty good. So I'm actually happy with how that turned out. And yeah, I think next step we will implement jumping. Also, I want to add this background that I had. It's not really perfect. I'm gonna change it, but I'll just add it for now. So let me just find this. Yeah, we already have it here. So let's rename this as background. It's 512 by 512, so I'm not sure how this will look, but let's see. So we would add this here. Let's have a background texture. And also need to unload it. Yeah, really need to fix this organization issue. We're gonna have a lot of textures that's gonna be need to be handled. So I'm gonna do that later, but not yet. Okay, so we want to draw this texture. So let's do that at the beginning here. So we have this draw system which can draw textures. We can also do it directly with Raylib, but I'm gonna do it here because this is using ZLM vectors. Raylib uses its own vectors. So I'm just gonna use this, and the texture is gonna be scene dot hello. Okay, background texture, and the position is 0, rotation 0, scale is 1, and this is false. Okay. Oops. So let's see how that looks. It might not fill the entire area because I don't think it's the same thing. Okay, it doesn't show anything. Great. Oh, I haven't actually loaded it in. Okay, so that makes sense. I'm surprised it didn't crash, actually. I guess Raylib has a safety measure for drawing unloaded textures. Let's go in here and we'll add it down here. So background texture. This would be a load texture as its root, and we append background.png. There we go. Now let's try. Okay, so there's our background. However, as you can see, it's way more high resolution, and yeah, it doesn't really fit the pixel art style, but at least it's something to have in the background. However, it looks more like a painting now, which is kind of cool, I guess. But let's just try and scale it up to fit the screen. So I guess a super easy way to do this is to just increase this to 2. We'll draw it in the middle of the screen and we'll be scaled up to 2. So there, at least we have some sort of background here. Okay. And yeah, so I think, yeah, I mean, I really hate the legs. The legs just looks like a bunch of spaghetti flapping around. Yeah, I'm gonna have to fix that. It looks comical, actually. But I think it's mostly to do with that one frame is missing, and sometimes it looks like the leg should be going down when it's going up and vice versa. And so yeah, and also when there's a couple of different issues with the animation, but I'm kind of happy with the hands. The hands look way better than the legs, at least, and the hair looks, I guess, good. And for the character, I also want to add like a weapon and stuff like that, and like a attack animation. And then when we have that, we can actually start implementing, adding some sort of monster and adding like combat physics. Because I'm thinking maybe, well, I'll play around with different things and see what I feel is fun. Oh, wait. Oh. Wait, where did that... Oh, I see. So I guess gravity is sort of deactivated by mistake if you're idle, because you set the velocity to 0. Well, unless you press down, it seems to activate again. Okay, interesting. Let's fix that issue real quick, if we can. Or if we can find it quickly here. So, if we're moving really slow, this should also only really be necessary for the X. But the issue is that you're moving really slow and you're not accelerating. Well, you are actually accelerating, you're accelerating upwards. So why wouldn't the gravity be applied? Because you are accelerating, right? But then when you stop, then we're locked in this thing, I think. Yeah, I think that's the issue. So we don't actually, right. So the issue here is we don't really want to, before the y value, because we were looking for collisions on the ground, the y value would always be 0, so it didn't matter. But now we actually don't want to change that. So let's just take the velocity y here. But we don't want to change. We don't want to change the y. Okay, so the gravity still applies, but we have such strong upwards force when pressing up that right, and then when you press left or right, it overrides the actual input. So that's, and you shouldn't. Okay, so let's fix the input, because the input's really it's not correct. Left and right should be fine. However, here we don't want else, we want if. So S we don't actually need to worry about. Now for W, I actually want this to be something, but it should also say if the current velocity of y wait, no, if we are on the ground is a more better way of saying it. So maybe we actually do want this collision here. Yeah, let's actually have this as well, because yeah, and then we do well, let's just build this into the player for now, because that's where we need it. Let's just say that if we're on the ground, let's no. I was thinking of adding an init function, but I'm not going to bother with that right now. So we should get a thing here. So let's just do on grounds false. And here we actually don't really care about. So let's actually say component plane component. So this would be maybe plane components. And so what I'm thinking is we checked for the collision. If the normal y is -1, that means we are colliding with the ground, right? At least I hope so. And then we actually want to try get the player component with non-static key, which is the entity. And then we don't really care about this. What we do is we say, if we have a player component, then we get the component here. No, that's this. And then we actually set on ground to be true. Okay. And I guess also that we want to set it to false whenever we are not colliding. So I guess we could set this like we do this here, and before we do that, we get the player component. Player components from player, and we set the on ground is false. So we start out by assuming that it's false, and if we get a collision, then we set it to true. Right, and now we actually need the scene here. Okay. Okay, so now we set the on ground, but we're not using it. So the on ground should be true whenever we are on the ground, and it should follow along with this handle input. And when we are on the ground, we should be able to jump. So let's say if we are on the ground, we actually do this. And this jump might be too weak, so we can scale it up by changing this value here. But let's just see. Yeah, it's way too weak. Basically nothing's happening. So let's add a little bit of force there. Okay, still nothing. I mean, it might just be that the ground doesn't work. Let's add like a huge amount. See. No, nothing. Okay. So we need to be on the ground, right? Okay, let's actually bring this up again. Check the... And we need to add this logs again, so... So on collision. So what I want to do is I want... Oh, you know what? We're not getting any collisions because I actually disabled that in the physics system. Whoops, 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 whoops. So let's go in here. Yeah. We need to do this again. And we also need to make sure that this is called, yes. Okay, now let's see. Whoa, okay. The jump was way too fast, okay. Or way too strong. Yeah, handle input. Let's change it back to, I guess, 100 and see where that lands us. Okay, yeah, we get a little bit of hop, 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 hop. Okay, this concerns me a little bit. If I hold it in, it seems to work. It seems to be more forceful when you first hold it and then, yeah, so that's a bit weird. It should be the same. And then sometimes it's like really, you're jumping really fast. So that's weird. I wonder why that is. It might be that it counts as being on ground for longer. Yeah, it might be actually because the physics system. No, it should be the same for each frame. Let's actually check this. So let's say jumping. So it should say jumping one time. It does. Okay, so it's only one time. However, the force gets weirdly frame dependent, it seems. I mean, I'm thinking about logging some stuff. Let's do it at the end here. So let's log, or let's do it before the physics update. So let's log player velocity. Actually, player acceleration, player velocity. So let's get the player body here. And no, player body, clone acceleration, clone velocity. So let's check that. Hmm. Okay, it's logging a bit fast here. But it actually does. Yeah, you can see here. Whoa. Okay, yeah. So that's the like the impulse or whatever. I don't know what to call it. I don't know actually what an impulse is, but this is where we actually do the jump, which is a weird number. Let's check if we actually see this. Because we did a jump here. So it ended at 45, 45. Okay, and this is exactly the same, and then the y velocity negative 125, 34. Whoops, no, I want this. Yeah, and that's okay, so it's like different. Oh, but it started out at 15. Wait, why is this fluctuating? Is it like bouncing up and down on the ground? Maybe that's the issue. Is it because the infinite mass? Yeah, we should really come to a rest at the velocity as well. Maybe it's because of the restitution. Let's actually remove the restitution. So let's make this 0. We're not gonna have that kind of physics unless we explicitly do like some sort of mushroom that you can jump on or something like that. But it's not gonna be. Yeah, it's not gonna be. Yeah, but definitely when you. Yeah, it's still got some weird like restitution stuff happening, I think. why? What happened here? Yeah, I mean, okay, so this is the same, so that's good. But then this is like way off, way below whatever was before. So I have no idea why it's so low this time. So that's like really inconsistent because before it was like, wait, but here we've got 89. Is that just before? Okay, so that's just before we land. And then we actually land, so we're down to 0.02. But we should go up to like 100, like the same as the other one. I'm not sure why it's so low. Is it because of the frame? Because because it's, wait, is it because it's time dependent? Because this only happens in one instance of a time, then it shouldn't be acceleration, maybe then. It should just be velocity happening. But that's weird. That means that the same force will have different, like this impulse, or will have different outcomes depending on how long the frame is. Because once the frame is gone, this holds for one frame. So that's the issue. It should really be like a time, like within a time window, this will happen, because then it's like synced to the time and not be, yeah. So, but I wonder, even if we add it as a velocity, no, if we add it as a velocity, it should work, yeah. So we should actually, let's see, because we do have, I'm not sure if we have this. Let me just check if impulse is the correct term for this. Impulse. The impulse of a force is the force of it. It's the force times the time. And a constant force Fx for a time t. Okay. Yeah, I think that's kind of what I want. So it's like, I mean, it's like adding velocity directly, however you take mass into account. But in physics, you can't have like instant time, so it has to be over specific. I guess that's why you need that thing. Okay, so let's go into physics body. So what I want to do is I want to go in here. I want to go to rigid body. And we have apply force. I also want apply impulse. But what this is going to do is we are going to grab not a force, but an impulse, I guess. And this, we still want mass to be involved, I believe. But this would actually be velocity and not acceleration. And then we actually change the acceleration here instead to be velocity. Why? All right. So now we can use apply impulse instead. Let's go back to where we were. And we were in somewhere. Handle input. That's right. I'm a bit tired. It's pretty late. Getting pretty late here. I should probably stop here soon. Okay. So instead of doing this, I actually want to apply an impulse. And the impulse is going to be 0 and negative, I guess. Pixels per meter times 15,000 times 100 or negative 100. So this would be the jump force. Okay. So this might be overkill. I'm not sure if this is correct since we don't have time now, but we might just add time. No, because what we really want, we want this force applied over a certain amount of time, I guess. But couldn't the time be instant as well? Yeah, let's just see how this works. So I just want the jump to be consistent, basically. So, okay, we don't have player body. Okay, so we need to get it here. Okay, and this might be super overkill here. The jump force might be super. Oh wait, I just noticed the negative there. Whoa, instant teleport. Okay, let's just remove that 15,000. Let's try this. Okay, now is nothing happens instead. Okay, let's try 1,000. All right. Okay, now you see it actually is more consistent. So let's escape, check the logs. And you can see it goes to about 9451. And yeah, it's a little bit of fluctuation because of the weird restitution, I believe. I mean, I set restitution to 0. So that should actually not have any impact, I think. But it seems consistent. So yeah, that is way more consistent. I might need to add some time thing here, but I don't know. It seems to work fine. We do need to. I mean, I think it works good anyway. We do need to change this force. Let's add like, I don't know, 3 times. Okay. And it feels like the gravity is a little bit weak, to be honest. I'm not sure, actually. Maybe not. It feels a little bit off, but it shouldn't be. Is this high enough? I'm not sure. I don't really know how I want the physics to be, but at least he can jump now with a reasonable height. I mean, it's quite high for this dude. And yeah, that's gonna be it for this session. So we've got animations working, we've got friction working, we've got jumping, we've got the player direction, we've got the input fixed so we can't move around freely, and yeah, we got some background that we can look at. Yeah, I'm not really sure next time what we'll do, but I will think about something nice. Yeah, I think I'm gonna start with... oh yeah, as I said before, I think I'm gonna start with adding like a weapon and some sort of fighting animation. And then add some monsters that you can fight. Okay, so that's gonna be it for this video. Thank you very much for watching, and if you have any questions about SIG or this game, you can post it down below. All right, see ya.